Yeah.
Okay. So I'm using a Java program to connect and send information. So I'm connecting now. And as you see, this is the same as in the report, you see?
Yeah, I saw it.
So if I'm taking the Y slider, then it can up and down. And I can also set the delay time, so I can show you.
The speed.
Yes, the speed. So now it's about 5 milliseconds between each iteration when it's moved 1 degree. And also the z-axis, how far the leg will move. So this is one configuration I will show you. It's not very fast, but it's working. And we can also go backward. And then I stop it.
And that light in this
one?
Yeah, looks very strange.
Yeah, it moves a little bit up and down.
Up and down, okay.
And then I just make it to its default position. And I can also rotate it. So I'm just moving the slider. And when I and it's moved to that position. And another gate is this one. Let's see. This one is the best. And also backward. The reason why it's
rotating
is because one of the servos is moving worse than others. And you have also go left, then it's moving as it's rotating, and also the other direction. So now it's using all the legs. And we also have another a kind of special kind of gate, this one. Also backwards. And one that's quite similar, but it's very similar, but it's not so good that way. And the last one is, it looks pretty funny, but it moves quite okay. And as I mentioned, the delay time, let's put it high, so it's going to move slower. And it's using the sensor. When these are down, it's continuous. And if the sensor doesn't reply, you take the time in use the millis function. And if it's, for example, some of the functions use 1 second, some 3 seconds, then it will continue, so it doesn't stop.
So if the deadline is reached,
then it's just continue.
And then of the gates before these gates, before you show everything, is of the gates locomotion according to the sensor information. Do you use the sensors before?
Yes.
Of the gates, do you use the sensor?
No, I can show it. This one uses. And this one, okay.
The late time
was pretty high, so. And this one is the best, as you saw. And this one here uses. No, not this. This one.
Some you use sensors, and some cases you didn't use sensor.
The two that looks pretty funny, those who jump, they don't use it.
Good.
Yeah, that was all gates, and it's Bluetooth. And then I'm just going to connect this pin. And then it will show on the computer as a regular COM port. The only problem is it takes a little bit longer to connect, and you need to put a higher delay time in the serial read function. But yes, now it's lighting green, so I'm guessing it works. So now it's Bluetooth, and I don't think I need to show anymore.
Yeah. Yeah.
And also we have the information sent from Arduino coming up here, and we can also write, for example, if I write Y60, then it moves. So I can write commands. As you see, we have many Arduinos.
Yeah.
And the reason for that is because one thing is because of the pins. The Uno doesn't have enough pins to power everything, including sensors and stuff. And also, to make you want to move, for example, these two at the same time. It is possible to do it with one card, but you would have to make a very complicated program to do it. So therefore you can, now it's parallel.
And also the modularity of the control, like
yes. And you can different programs to each Arduino, and the master just sends commands to everyone.
So which kind of command do you send from the master to the slaves?
It's information. Let me just stop it here. And, for example, the height of the servos. And which type of movement it should do. Should it move like this, or should it move back and forth, and how far it should move. And then you can choose to send it to all of them at the same time, or you can send to one on one. And yeah, that's about it. And it's the same program really. It's just different buses. We use the I2C bus, and the slaves are programmed so that if I tell it to move forward, everyone moves the same direction.